Scientists estimate that our oceans suck in around a quarter of the carbon dioxide we emit. That's a colossal amount, something like 10 billion tons a year. And while that reduces the level of greenhouse gases in the atmosphere, it has the unfortunate side effect of making our oceans more and more acidic.
Having the opportunity to snorkel and dive in all of these areas that 15, 20 years ago were just amazing and abundant with life, and you could see all the coral and all the various organisms, urchins and starfish. And then to go back now, I mean, they're dead.
Claudia Benitez Nelson is a distinguished professor at the University of South Carolina School of Earth, Oceans, and Environment. Her research focuses on how climate change is affecting the oceans.
I'm really interested in the chemistry of the oceans and how the biology and the chemistry work together to kind of change the environment, the ocean environment.
She's also a self-proclaimed science mom. She's part of a group of climate scientists who work to demystify climate change on social media.
It's about really communicating the importance of talking about climate change, the impact that it has, not only in our environment, but really on our kids, and how we need to really invest in our future and our children, and ways to, let's just say, change the direction in which we are currently moving.
When it comes to the climate and the ocean, the need to change where things are headed is becoming increasingly urgent. Year after year, our oceans are becoming more acidic. To reverse that trend, scientists are now studying what would happen if we modify our waters to make them more alkaline. I'm Manjula Selvarajah, and this is Solve for X, Innovations to Change the World, a series where we explore the latest ideas in tech and science. And in this episode, we're exploring marine carbon dioxide removal. We're asking, should we geoengineer the seas to save the planet? But first, I want to take you on a little detour. I'm going to take you back in time for a short history lesson. At some point in the early 1770s, an English inventor called Joseph Priestley assembled a strange bit of apparatus. It involved several glass bottles, a bowl of water, there were tubes, some chalk, and also a pig's bladder, like a real bladder from an actual pig. It sounds like a recipe for some sort of dark magic, but Priestley was on the verge of a much lighter, you might even say refreshing, discovery. Priestley is the father of carbonated water. His contraption created carbon dioxide, which he collected in the bladder. When he shook it, the gas dissolved, and voila, soda was born. Almost 250 years later, scientists are once again taking a keen interest in that reaction. But this time, they're not looking for a new bubbly beverage. The stakes are now much, much higher.
The oceans really resist change. You have to add a lot of carbon dioxide before the oceans really start changing their acidity. And yet we can measure it. We've already done it. We're clearly on the acidity scale. You can see it happening. And at some point, that's going to be really detrimental to not just those organisms that need to use chalk, for example, to make their skeletons. But there's a whole host of organisms out there that aren't going to be successful. And that is really scary, because now think about seafood. Where do we get our food? Like fishing, all of that, like tourism, all the things. You can't go swimming. It's too acidic. There's no food in the ocean because you have made it extraordinarily a different place than it used to be.
The oceans are now 30% more acidic than they were before the Industrial Revolution. Claudia explained that change is faster than what we've seen in 50 million years. I wanted to understand, what is the potential of using the ocean itself as a climate solution?
Well, that's the big, exciting news, is that the oceans actually have a huge, incredible potential to serve as a mechanism to remove carbon dioxide from the atmosphere.
To reach net zero and help the planet return to the climate conditions of earlier decades, the International Panel on Climate Change, or the IPCC, has stressed the need for carbon removal technologies.
I mean, current models that we have about CO2 production and fossil fuel emissions basically say that, we're just not doing a good job of reducing that carbon dioxide release into our atmosphere. And so it means that there's no way that we're going to be able to kind of keep us from increasing our temperatures by, 1 to 3 degrees centigrade unless we have like zero or net negative global carbon emissions. So that's unlikely to happen as much as I would love it to happen. So we just need to be creative. And that's where the deliberate removal of carbon dioxide from the atmosphere is really the next big play. And the oceans, 70% of the Earth. So it makes sense that that would be the place where you might want to put it.
Researchers are now looking into a climate solution in the ocean that would have an added benefit of making it less acidic. It's a new carbon removal technology called ocean alkalinity enhancement. That may sound kind of academic, but it's actually a really hot topic right now among marine conservationists.
So my name is Will Burt. I am the chief ocean scientist at Planetary Technologies.
Until very recently, Will was working at the University of Alaska as a professor of chemical oceanography.
Especially when you're living up north, there is a really real climate change impact happening that is much more accelerated there. And, when you're working in that academic space and you're constantly writing papers about how things are changing, it can be a little bit daunting because you always sort of strive to have something that's more applied.
And so Will is working on a geoengineering project that has the potential to tackle two big issues: climate change and making the ocean less acidic.
The best way to sort of counter or slow down that acidification would be to add an antacid to the system, similar to how we as humans deal with acid reflux. We use an antacid to help solve that problem.
I asked Will to explain how it all works.
We at Planetary are proposing to do that literally, add an antacid into the ocean. By increasing the ocean's alkalinity or making it more basic, you actually allow it to take up more CO2 from the atmosphere naturally. And so you get this sort of double win.
If you add an alkaline to the ocean, it could help make it less acidic, but it does something else as well. It reduces the concentration of CO2 in the water. That means there's more space for CO2 from the atmosphere to get absorbed. My producer Ellie and I decided to do a little science experiment over Zoom to see how carbon and water interact.
All right, I'm going to pour a little bit in.
Ellie got some calcium hydroxide or lime water, which is a kind of alkaline solution, so that we could visualize how carbon dioxide gets absorbed. So you've already put in about 1/2 inch to 1 inch of the calcium hydroxide in. You've got your safety glasses, you've got all of your safety stuff on. Now put the straw in, and the way that I want you to start is, that there's CO2 in the air that you breathe out, right? And I just kind of want to see how much it takes. So start with blowing into that straw very lightly. Yeah, that's good. In the glass of tap water, nothing changed. But in the one with the added alkalinity, it grew cloudy. It's changing a little bit.
Ah, look at that.
Can you hold that up to the screen so I can see it a little bit closer? That cloudiness was the CO2 from Ellie's breath captured in the liquid.
One way of thinking about this is that the Earth is going to solve this problem for us. The oceans will become more alkaline and they will bring CO2 down, and it's going to take millions of years to happen. And we're going to be dead and gone by then. And so it makes sense to try and speed up something that is already going to bail us out. And it's also really important to remember that this is not the only solution.
Now, I think about this idea of the drawdown of oceans and that you're hoping to change something that gets them to take in more CO2. I mean, given the nature of open water, how do you know that this works or could work?
Yeah, that is a big question in our space right now. We do this in the lab, and it's very easy. In the ocean space, if you're in the right sort of system, you should be able to measure how you've impacted the ocean chemistry. So making that little piece of ocean less acidic should be measurable. Probably only very close to where you're doing the addition, probably in a very localized area, but that should be possible. And that's one part of the proof of concept. Now, that invasion of CO2 from the atmosphere into the ocean, that process takes weeks or months to occur. And by the time that starts and certainly finishes, the water you put the alkalinity in is going to be very far from where you started. The prospect of measuring that directly is by far the most daunting one we face as a community.
But figuring out what happens to these additives and whether they're working isn't the only challenge facing the nascent industry. It also has to work out how to get the alkaline into the oceans in the first place. Planetary is working on adding alkaline materials to existing pipelines that take wastewater out to sea. But there are plenty of other ideas being explored. Some people have suggested fitting ships with mechanisms to disperse it into the waters. Others believe that these minerals should be spread over beaches so they can be washed away by the tides. But in a waterway about 2 hours north of Halifax, another idea is taking shape, using rivers instead.
My name is Eddie Halfyard, and I'm the Chief Technology Officer for Carbon Run and a co-founder.
We've heard you referred to as the fish guy. Is that okay? Is that a term that you know that you're being called?
I've been called plenty worse, and I am proud to wear and carry the flag for fish. Yes, that's fine.
Eddie is also a research scientist with the Nova Scotia Salmon Association.
We've done research, everything from taking blood from them to running personality trait behavior analyses on them. Their brains are less plastic in acidic environments. They don't react to predators the same. They don't feed as aggressively. There's a whole bunch of different things that can happen to these fish, and it's really complex.
To help restore the ecosystem, Eddie and his colleagues have been regularly adding alkali to the river, this time limestone. It's a technique that was pioneered in the 1980s to help salmon in Sweden.
And all this is a machine that takes crushed up powdered limestone and administers it into the river. And so it operates all the time, 365 days a year, constantly putting this lost alkalinity back into the river.
The results were encouraging. Since they neutralized the river's acidity, the population of young salmon tripled. And that got Eddie and his colleague Shannon thinking.
My co-founder, Shannon Sterling, and I were spending a lot of time on rivers. And it came to us that there's something going on in the carbonate cycle. There's something going on in relation to CO2. So we started to dive into it a little bit. I'm just downstream of the lime doser, picking up some rocks. On these rocks, I can see critters scurrying around the bottom on the underside. Mostly what I'm seeing are small caddisfly larvae, mayfly larvae, and in some cases, beautiful big golden stoneflies. These organisms are pretty indicative of a healthy watershed. Before this liming program started, there was very few of these insects, which are so important to the base of the food chain.
It turns out the health of a river matters a lot for storing carbon. The healthier it is, the more carbon gets absorbed. So they wondered whether by helping the salmon, they could also help the climate.
It's a unique scenario where the work that we're proposing to do to address climate change is undoing the harm that's already been done. It's addressing the pollution that's already out there with a carbon benefit.
Both of the climate solutions I looked into for this episode are hoping to sell carbon credits. But scientists trying to parse out the effects of these projects are in a very real sense looking for droplets in an ocean. Here's Claudia, the oceanographer.
We don't know what the natural uptake of carbon dioxide is from our atmosphere into the ocean. We don't know the magnitude in terms of how it varies regionally from the coast up to the open ocean. We don't understand how it might vary seasonally or interannually. And so now we're thinking about deliberate changes to an ecosystem that I'm not sure we have really well defined at this moment.
We tend to think of the oceans as a fairly uniform mass, but they're more like a layer cake with water at different levels that don't easily mix. What happens to carbon as it's absorbed by different parts of the sea is something we're only just beginning to quantify. Quite reasonably, tampering with the balance of something we don't yet fully understand makes some people nervous. To get a better sense of the social dimension of this technology, I spoke with Sarah Nawaz, a social scientist.
I think that we are at a place with ocean-based carbon removal and with alkalinity enhancement where it's a bit of a watershed moment where we're not really sure how it's going to go, how the public is going to respond to this. And I think that it's really important, in my perspective, that research is done to better understand what those potential impacts are and whether this can be done well and safely. But while that's happening, I think we need to be very careful with how we talk about it with people in areas where we're considering doing this kind of work.
Sarah is the director of research at the Institute for Carbon Removal Law and Policy at American University. Part of her work involves developing best practices. That means she pays close attention to how the public debates and makes sense of new carbon removal technology like alkalinity enhancement.
We have a lot of associations with the ocean. We have a lot of attachments to the ocean. People have aesthetic or spiritual relationships to the ocean. I think it's a special place to a lot of people, and that means that people are going to be wary of things that they perceive might be mucking about with the ocean, messing it up.
But it's still early days and research is ongoing. Part of its success depends on the ability to persuade the public that this bet is worth taking.
I think we need to have a lot more transparency and honest conversations about what carbon we're removing. So taking a big step back, the idea with carbon removal is to remove the carbon from the atmosphere that we can't easily abate. But we shouldn't be just removing carbon from the atmosphere so that some exec can fly their private jet, right? And I think finding policy mechanisms to make sure that we have more transparency about where the removals are going to, what they're compensating for, would be really important.
So I want to ask you, are you excited about these ideas and technologies? What excites you about them?
Yeah, I think these are really fascinating innovations, and I do have a lot of excitement about them. I think part of why I get really passionate about engagement and doing engagement well is I would like to see these technologies done well, and I would like to see them get off the ground. I think so much of the rhetoric and conversation around climate change right now is pretty doom and gloom and pretty hopeless, and I know a lot of people that have a lot of grief over the climate, and I think this is a space where there's potential to feel optimism and hope, but I just don't want to see this being done in a way that immediately just gets it kicked off the table as an option.
Regulation and policy are going to be key elements, not just to help bring the public on board, but to ensure the technology is being used in the right way and not as some get-out-of-jail-free card. It can't just be business as usual. Meanwhile, there's been a huge rise of interest from the business community. Meta's former CTO and a group of other business leaders have committed $50 million to research and develop the technology. I wanted to get a better sense of what's needed to monitor these projects.
The ocean presents a very compelling target for carbon removal strategies that have the potential to scale towards gigaton level removals.
That's Matt Long, one of the founders of Seaworthy. He and his co-founders helped build some of the models used by the IPCC to predict what's ahead for the planet. They're now working on models to validate these new carbon dioxide removal, or CDR, projects.
There has not yet been a concerted, well-funded effort to ensure that those CDR, or carbon dioxide removal strategies, are working and that the impacts that they have on ocean ecosystems are well quantified and acceptable.
Matt and his co-founders saw the need for better oversight in the industry.
We are strongly committed to enabling the ocean CDR industry to grow because we believe it has the potential to contribute to climate change mitigation. but we want to be able to ensure that it can grow on the basis of sound science.
The idea is to build a set of quantitative tools that can be used by industry stakeholders and the public to verify carbon credits.
It's absolutely critical that we begin to build the infrastructure necessary to remove carbon from the atmosphere at gigaton scales.
In order to get to that gigaton scale, however, ocean-based carbon removal projects have to start somewhere. The reality is, pilot projects do involve a certain degree of risk for nearby communities. Here's Will.
We're looking at tackling a very big global problem. And the idea of a smaller community having to take the risk in an initial project to sort of prove that out is a big challenge. It's a big problem that we have these small scale projects that are leading towards this thing that is meant to be for the greater good of the world. And so we have to work with communities, and I think it's going to take some time. It's going to take some time for people to get used to this idea and let it sink in. But, it comes back to the fact that even a small bay of the ocean is a very big place.
We first started working on this episode back in the spring, but this technology is developing at a rapid pace. We reached out to Will for an update.
Since we last spoke, we have been finalizing our preparations, really, for a field trial here in Halifax. So what we're doing in Halifax Harbor now is Planetary has sourced and tested an alkaline material, and we are mixing this mineral into what's called a slurry, and then we're dosing it, adding it into a small part of Halifax Harbor. And then we're monitoring what that addition of alkalinity is doing. So we're monitoring the chemistry, we're monitoring the biology, and then on top of that, the Dalhousie University team is coming in at regular intervals and doing independent research. There's a lot of data and number crunching that needs to happen. But what we're seeing is that the pH of the water, in the vicinity of where this seawater mixed with slurry is coming out, the pH is higher than it was before you added the material. That is exactly what we want to do. We want to decrease the acidity of the water ever so slightly. That means that the amount of CO2 gas in that seawater has gone down enough for the CO2 in the air to invade and fill that void. But it looks as if we are generating, a measurable change in the chemistry, which is really exciting.
The urgency for climate action feels greater than ever. In fact, when we were finalizing this episode, we got an email from Eddie Halfyard, and what he said really hit home. This summer, he's had to contend with wildfires near Halifax that displaced him from his home. Then the area was hit by extreme flooding. Across Canada and the world, people are experiencing what it means to adjust to a changing climate. But for the story of marine-based carbon removal, things are still developing. I'll be curious to follow where it goes next. Solve for X is brought to you by Mars. This episode was produced by Ellen Payne-Smith. Lara Torvey and Heather O'Brien are the associate producers. David Pattison is the senior producer. Max Swain composed the theme song and all the music in this episode. Gab Harpel is our mix engineer. Catherine Hayward is the executive producer. I'm your host, Manjula Selvarajah. Watch your feed for new episodes coming soon.
Mars works closely with ventures to help them scale their innovations. It created the Mission from Mars initiative to help speed up the adoption of climate solutions. Mission from Mars thanks its partners, HSBC Bank Canada, Grantham Foundation, RBC Tech for Nature, and Peter Gilgan Foundation. Learn more about the program at missionfrommars.ca.